All right, by now you should be done your warm-up. Number one, we have a spinner shown below. There's 5 segments. 4 of them are greater than 1. There is 2 odd numbers, 1 and 3. So 2 out of 5, you put that in a calculator, you multiply it, you end up with 8/25 is the probability. Number 2, first off, we have to figure out how much did the Spectrum's internet go up. $82 times 15% means the price went up $12.30. That means the new price, when I add it back in, because they still have to pay the $82 plus the increase, means they now pay $94.30. That's 1 month though. They wanted 1 year, 12 months. When you multiply your answer times 12, you end up with $1,131.60 for 1 year of service. Number 3, 2 out of 7 fish are predators, meaning 2 out of 7, and they want to know if they increase the sample size up to 500. So 2/7 of means times 500 means your answer should be 142 6/7. Number 3, we have to break this problem up and set it up correctly. Everything, the expression is all over 3. So the real problem we were solving was 10 equals x divided by 3 plus 7/3. First step, we're going to subtract 7/3. We end up with 7 2/3 equals x divided by 3. We're going to multiply each side by 3 to isolate x, and our answer is positive 23. All right, couple of notes we're going to take today. So starting on this slide, we're going to write an inequality to represent a real-world situation. We're going to list the solution set containing 3 values. So the temperature x is colder than -2 in Minnesota. X is less than -2. That means I'm looking for 3 numbers that make it true. Well, since it's or equal to, I can start with -2. Less than numbers all run to the left of a number. So -1, -1 and 0. So we have to think, well, these numbers are not to the left. So the first thing that this student did was their solution set's incorrect. -2 is okay because it could be or equal to, but the number that's to the left of -2 is -3. And the number to the left of that is -4. Moving on, a little bit of notes. So we have an inequality, a mathematical statement in which there are an infinite number of solutions. The inequalities contain one or more of the symbols. We have greater than, less than, greater than or equal to, less than or equal to. Again, that underline underneath the inequality symbol just lets us know that the value could be or equal to. Below that, we have a chart we're going to fill out. So the first one I go ahead and did for you. If you want to take a pause and try some of the ones underneath of it, this is what it looks like. So I would read this as x is greater than 15, a number greater than 15. And a real world example would be a student, a basketball player, made more than 15 shots. That means they could have made 16, 17, or 18 shots or more. That's what those dots say. We're going to continue in that direction. Second one, I would read this as y is less than or equal to 3. A student needed 3 or more points to get an A in math. Well, 3 numbers, I know 3 is equal to 3. I'm looking for 2 more numbers that are at least less than. So 2 and 1, that would be our solution set. Next one we have m is greater than -5. M is greater than -5, and I had a student owes less than $5. Well, since it's just greater than -5, I can't use -5. I have to use all the numbers that are greater, which run to the right, meaning -4, -3, and -2. Last couple we have here. Okay, A is less than or equal to -2. Again, since it says or equal to, I'm going to start my solution set with that boundary -2. I'm looking for numbers that are less than to the left, meaning -3 and -4. All these 3 numbers are all to the left of -2. And then the very next part, what is the difference? We're going to think about some problem solving skills, comparing and contrasting some things. So what is the difference in the solution sets between the 2 inequalities shown below? Let's think. There's something missing in one of these, okay? We would read this as n is greater than 6. We would read this one as n is greater than or equal to 6. So the big difference between here is this solution set does not contain 6. This solution set does contain the number 6. Okay, so that line's a big deal because one of them has 6 as a solution, the other one does not. Another quick write we're going to have here, again, just copy down notes, or you could use some independent thought to answer this. In the inequality, m is greater than 9. A student generated the solution sets 10, 11, and 12, ... Now, I already kind of mentioned this in this video. Why would a student put ... at the end? What do those dots mean? Well, let's think about it. These numbers are continuing. 10, then 11, then 12. The next number would be 13, 14, 15, 16, and those dots are going to continue. So basically, these dots, they mean that there are infinite answers. And that just means that because numbers never end, they go on to infinity, positive or negative infinity, there's an infinite number of numbers. Last things, there's a little bit of notes to write in this next slide. So how to graph inequalities, the strategies. The first one, we have to write the inequality. The second thing, we have to list those 3 possible solutions that can make that inequality true. And the last thing, we shade with an open circle or a closed circle and in the direction of our solution set. So below, I have a little bit of an example. We have a number is greater than or equal to negative 14. So the first thing is I took those words and I translated it into math. Then I came up with 3 numbers. Well, I know it could be equal to 14, so I started with 14. I needed 2 more numbers that were greater than to the right, 15 and 16. That's 3 numbers right there. Last part, going back to yesterday's notes, okay? And again, you have this right in front of you. So we had an open circle. If we had greater than or less than, we have a closed circle for less than and equal to, greater than or equal to. Well, I have less than or greater than or equal to, so I chose a black dot, a full black drawn in dot. And all these numbers, 15 and 16, are on that number line to the right. Very easy to see on my board. I shaded it in red. From there, one last slide here. Again, if you want to give this one a try on your own, you can do so. A number that is less than or equal to 15, well, I'm going to use a variable to represent a number. Less than is that symbol, or equal to 15. Again, 3 numbers that satisfy that. 15, I'm looking for less than. 14, less than. 13. I would have a closed-in dot because it's or equal to, starting at 15, and all these numbers are to the left. So I would have a graph that starts at 15 and goes to the left with a closed circle. John has more than $180 saved. Well, it doesn't say that he could have $180, so we're going to have to go with John has greater than 180. Again, 181 would be the first number, 182. He could even have 200, a million, a bazillion, doesn't matter as long as it's bigger than 180. This time, though, I'm going to use an open circle because it's just greater than, and all these numbers are to the right of 180. So again, 181, 182 would all be to the right with an open circle. Last problem, Mike needs at least 15 points. So Mike needs to get more than 15 points, but it says at least, meaning he could get 15 points. So we're going to say that Mike has to get greater than or equal to 15. Well, he could get 15 to get an A. He could get 16 to get an A. He could get 17. He needs more than 15. And then again, I'm going to use a closed filled-in dot because it could start at 15. And again, all these numbers are to the right, 16, 17. Last part of today's assignment is going to go to this bit.ly. Yes, my bit.ly, not Mr. Johnson's bit.ly. You're going to use the bit.ly inequality review 708. Capital I, capital R. There's about 20 questions. A lot of them you don't have to show any work for. Just write down your answers just in case you get kicked out. Okay?